Morning, everyone. My name is DJ Kumar. Welcome to Risk Management Professionals webinar series. Our producers, Karine and Sarah, are going to be keeping us operational and taking questions if there are any. Just some housekeeping duties. We're using a GoToWebinar interface to support our presentation. If there are any technical difficulties, please feel free to contact our office at the number shown on the screen. We also have staff available to assist you with troubleshooting. And there's a dialog box that's available for questions, so please input any questions you have, and we'll address them at the end of the presentation. Okay, so today I'm going to be talking about the importance of P&IDs and labeling equipment at facilities. Before I do that, I'm just going to briefly introduce our company to those who are new to our webinar. Risk Management Professionals is a full-service engineering consulting firm that provides consulting services for facilities that are required to submit the RMP that's regulated by the EPA, PSM that's regulated by the OSHA, CalARP submittals. In addition, we also facilitate HAZOP and LOPA studies and other hazard identification techniques, along with a variety of different things that are outlined on our website. So feel free to go through our website and identify anything that we can help you with. Okay, so a quick outline of the presentation. First, I'm going to talk about the purpose of P&IDs, how to utilize them. Just as a disclaimer, I won't be going too much into detail about what P&IDs look like and how they work. We're kind of working on the assumption that you have a basic understanding of how these work. And if there are any questions about P&IDs, feel free to put them in the question box or send us an email. We'll get on them. And then to continue on, we'll talk about the key information that can be found in a P&ID that's useful for HAZOP studies, importance of P&IDs during HAZOPs, and then round it up with some labeling initiatives that facilities should undertake. Okay, so what is the purpose of a P&ID? The purpose is to show the layout or schematic of an overall process or system and the functionality of that system. Also to show the sequence between components and also the sequence of equipment that are shown in a P&ID and what order they go in. That way you can identify the flow direction. And also show the relative orientation or the configuration of the equipment. A lot of times things can be backward even though they're supposed to be right side up. So those are some things to keep in mind. And lastly, to display connections between equipment and instrumentation. Just as we talked about the importance of what a P&ID is for, it's also important to know what P&ID is not supposed to be used for. It's not a physical representation of the system, which means that whatever's on the P&ID is obviously not to scale. Oftentimes, two items that are side by side on a P&ID can actually be in different buildings or opposing sides of the facility, which can kind of make it confusing. It's a mistake a lot of young engineers often make, so it's something to be cognizant of. And obviously, P&IDs are not process flow diagrams or PFDs. A PFD is more of a flow-based diagram, as the name indicates, to show the flow of chemicals and equipment involved. All right, so how do you utilize P&IDs? P&IDs are especially helpful during HAZOPs. They help the HAZOP team understand the entire process, and you break down the process into different individual systems, what we call as nodes. And these nodes allow the project team to stay organized during the HAZOP study and allow them to stay aligned in exactly what specific node they're talking about. A lot of times, incorrect or outdated information on a P&ID can slow down the entire HAZOP, which is why it's important to make sure your P&IDs are updated along with making sure that they're an accurate representation of what's actually out in the field. And if you have an incorrect P&ID, then most likely the HAZOP will be invalid. And there's some key clauses where you can go around that, and I'll talk about that later on. This is also where the importance of labeling comes in, because if you have a appropriately labeled P&ID in your system and that's been verified in the field that that's exactly how the P&ID is, that streamlines the entire process of the HAZOP. We've been involved in several studies where there's been a little bit of a slowdown in updating the P&ID and reflecting the changes in the actual facility or vice versa, which has kind of caused a little bit of rework because it causes us to do a little bit more busy work to kind of clean everything up. So this is an example of a P&ID that's been broken down into different nodes. Obviously, this is a fairly complex system, so any P&ID that looks like this or a little bit more complicated, there are going to be more nodes, which means that the importance of each valve, each tank, each column, whatever you have in your system, labeling them, making sure that the configuration is according to what P&ID says is that much more important. So the more complex the system becomes and the more intricate the nodes are, the accuracy of P&IDs become more and more important. So, which is why we're kind of doing this webinar to explain that that's why P&IDs should be up to date. Okay, so when you're doing a HAZOP study, a lot of times P&IDs may not have all the information you need to complete the HAZOP. So it's perfectly okay to combine them with other diagrams, such as PFDs, electrical diagrams, site maps even, and chemical detection maps. This is just a way to kind of show a comprehensive overview of what the system has and to make sure there's no gaps when you're going through a HAZOP. All right, so some key items in the P&ID themselves. When you're breaking down in terms of the different types of equipment, we generalize it in terms of pipes, valves, and general equipment. So for piping, obviously you make sure that the pipe size, the diameter is labeled on the P&ID. If possible, name the pipe, which is less important than the actual size. This makes it a little bit easier to identify in the facility when you're walking it down. And also the material of construction. And this is important so that when you're actually going through the HAZOP, you can assess the adequacy of the pipe for the service it's being used for, which might help identify any corrosion possibilities, any failure possibilities that may come up during the scenarios. For equipment, valves, tanks, any of those sort of things, knowing the type of equipment that you're talking about and the size is obviously the most important. And naming them according to what it's named out in the facility is obviously another thing that's important. And this obviously helps helps assess the feasibility of the configuration, and if anything is suspicious, maybe due to an MOC where there was a slight change in the system that has not been reflected in the P&ID, that's what would cause someone to go out and make sure that the P&IDs are up to date. Going on to safety systems, obviously every plant will have some relief valves, maybe some flare stacks, flare systems, and emergency trips. All those are useful to be shown in P&IDs, just so that when you're going through a system from end to end, you identify certain situations that are safety mitigation. You can identify these as controls when you're going through each scenario. So having these properly identified, making sure that they're up to date. If there's a relief valve that's no longer in commission, make sure it's removed or crossed out in the P&ID, and vice versa. If there's something that's new added, make sure it's up to date immediately, because this oftentimes is what is going to be driving the HAZOP, is making sure that when we talk about what controls are in place to take care of any serious event, these are the ones that will help bring down the severity. From an instrumentation standpoint, obviously instrumentation and controls, they help define the process, so the configuration can be determined. It helps the HAZOP team or any team that's looking at the P&ID to kind of identify the failure modes of each control that you're looking at. And also it helps the team identify and understand the controls and interlocks in the system. So what is the importance of all of this? I know I mentioned briefly that having inaccurate P&ID would lead to an invalid HAZOP. And that's predominantly because a lot of times when P&IDs updates are made to P&IDs, the changes are not immediately reflected in the plant. And so a lot of times things are forgotten and people don't really take into account exactly all the changes that are made, and they don't make the changes immediately to reflect them in the plant, which then when it comes down to the HAZOP time or facilitating the PHA, we go into the facility and we're reviewing the P&IDs, and people realize, oh, well, the P&ID doesn't actually look like, or the facility doesn't actually look like what the P&ID says. So then there has to be a revalidation process for walking the entire P&ID down, walking the facility down, redlining the P&IDs to make sure that everything's up to date. It causes more of a headache than needed. So it's always a good idea to verify the P&ID against what's actually out there, and it's always a good idea to do that before an actual HAZOP. Some indications that a field verification is necessary when you're looking at a P&ID is that the revision block at the bottom right of the P&ID often is outdated, or the date does not reflect anything recent. And the equipment information is also not up to date. These are things that you can probably identify internally if you know that there's been changes in the process, or any changes that have been made to equipment, such as maintenance or any add-ons. Those are the type of things that would help you identify if the P&IDs are up to date. All right, so I'm going to wrap this up with talking about how labeling comes into play. The reason why accurate P&IDs go hand in hand with labeling is because, as I said before, there's often a delay in updating one over the other. So when you're labeling your valves, you're labeling your pipes, and you're making changes in your P&IDs at the same time, then that's where you kind of run into the issue of doing double work. So we just wanted to go over some basic labeling policies and techniques that you guys should follow. So according to ASME standards, these are the color schemes that you guys should keep in mind when you're putting on labels for your pipes, your valves, or whatever equipment that's servicing a fluid. For a fire quenching fluid, make sure you use white on red. For toxic corrosive fluid, make sure it's black on orange. Make sure for a flammable fluid, make sure it's black on yellow. For combustible fluids, white on brown. And for any type of water, portable, cooling, boiler feed, or any other type, it's white on green. And for any compressed air or compressed gases, white on blue. And there are some customizable options available if there's something special that your facility is working on. So when you're talking about labeling pipes, obviously a lot of this comes down to common sense. For pipes above you, obviously don't label things backwards. Label them left to right. For vertical pipes, make sure that it's in a position where it can easily be read. Obviously, there's no right way of doing it because the orientation is dependent on how you're looking at the pipe. When you're looking at T's, make sure that there's sufficient labeling on either side of the T's, going in and out of the T's. If the pipe is going into a wall and out the other, make sure the same label is on one side of the wall as is on the other. For elbows, make sure that it's on either side of the elbow, adjacent to, to show the flow direction. And as a general rule of thumb, make sure that the label is repeated every 25 to 50 feet. This is honestly the most common reason why it's very difficult to walk down a P&ID is that there might be one sticker on a pipe indicating that it's a city water line, but if you walk 30 feet and you're following that line, you don't really see that label again. You're in a piping spaghetti. You can kind of get lost. So making sure that these labels are consistently available throughout the facility is going to help streamline your entire system. Just another quick information on the size of the labels. I'm not going to go into exactly what this says. You guys can review this. But depending on the size of the pipe, obviously adjust your label accordingly. The goal is to make sure that everyone out in the facility can read the signs from a reasonable distance. So don't make the labels too small. Don't make the labels too big, so to the point where it curls around the pipe. An example is shown in the picture below. So that's kind of a rule of thumb. For valves, it's a little bit easier to label. Obviously, you can use dog tags, stickers. It's a little bit more accessible in a way, and valves are actually probably more important than pipes because, at least for me personally, when I'm walking down a system, valves kind of represent points in a line that are easiest to identify. Now that becomes complicated if you're looking at a system where there are 25 valves in parallel and you're trying to figure out what line belongs to which without any labels. So labeling valves is very helpful for any engineer that's walking down the system, and it will help them kind of make sure that it helps them do a sanity check when they're walking down the system. And often when you're labeling valves, you have to keep in mind that because if these are valves that are commonly opened or closed, it can maybe wear away the labels and might tear off the dog tags. So proper upkeep is also very important to make sure that you have some kind of a PM cycle on your labels to make sure that things are up to date. That's kind of all we had for this presentation. Upcoming webinars, we have a couple coming up in the next few weeks. On April 24th, we're going to be talking about meeting safety standards for gas-fired heaters. That'll be presented by John Johnson. On the 10th of May, we'll be talking about the differences between an emergency action plan versus an emergency response plan. That'll be presented by Ryan Bray. And we will also be presenting at the Global Congress on Process Safety, or the GCPS conference, and a couple of our engineers, including Karine and Steve Marr, should be there to present some of our topics. So feel free to stop by if you guys will be attending that conference, and make sure if you have any questions, make sure you can ask us there. That wraps it up. So at this time, if there's any questions, I'll be happy to answer them.
All right, we do have a couple questions. The first is, what is the difference between P&IDs and PFDs?
Okay, it's a good question. So P&IDs and PFDs are often, I know when I was in school, I would confuse them early on in my engineering career. So one way to kind of think about the difference is a P&ID is just a more complex version of PFD. PFD doesn't always show what's available on the P&ID, and it will just often show the flow direction, the basic chemicals being used, and maybe the properties of the chemicals that are being fed into a system, along with the equipment. It's just a generic overview of the entire process, whereas a P&ID is more intricate and it shows major equipment and some major loops and minor loops in the system.
It looks like we have one more. Can you do a HAZOP with a P&ID that is in the process of being updated?
So technically you can, but you have to make sure that you walk down the facility so that you redline them appropriately. A lot of times, obviously, the timing isn't up to everyone. It kind of when you're doing the HAZOP, the timing situation isn't always ideal. So if you do have a P&ID that you think is outdated, make sure you walk the system down, redline it, so you have appropriate comments, and that way the entire team is aware of the changes that are being made to the P&IDs. Once the P&ID is updated, it's always recommended to revalidate the HAZOP to make sure that everything is still kind of in check and make sure that all your scenarios are still valid, all your controls are still valid. It's just a best practice to make sure that those things are taken into consideration.
Okay, that is all the questions for today.
Thank you.